In today's video, we will be discussing the critical angle formula and total internal reflection. So what is the critical angle formula? The critical angle formula is the inverse function of the sine. It is the angle of incidence corresponding to the angle of refraction of 90 degree where the light ray gets completely reflected inside the medium itself. Critical angle formula denoted by critical angle is equal to sine minus 1 multiplied by nr by ni is defined as the angle of incidence which provides a 90 degree angle of refraction. Now let's discuss the critical angle formula for a couple of mediums. Critical angle formula of glass. We already know that the refractive index of glass, N1 is equal to 1.52 and the refractive index of air, N2 is equal to 1.00. Using the critical angle formula, critical angle is equal to sine minus 1 multiplied by N2 by N1 and applying these two values as critical angle is equal to sine minus 1.00 by 1.52. Therefore, the critical angle of the glass is 41.1 degree. Critical angle formula of diamond. We already know that the refractive index of diamond, N1 is equal to 2.42 and the refractive index of air, N2 is equal to 1.00. Using the critical angle formula, critical angle is equal to sine minus 1 N2 by N1 and applying these two values as critical angle is equal to sine minus 1.00 by 1.52. Therefore, the critical angle of a diamond is 41.1 degree. Critical angle formula of water. We already know that the refractive index of water, N1 is equal to 1.00 and the refractive index of air, N2 is equal to 1.33. Using the critical angle formula, critical angle is equal to sine minus 1 N2 by N1 and applying these two values as critical angle is equal to sin minus 1 multiple by 1.00 by 1.33. Therefore, the critical angle of water is 48.75 degree rounded off to 49 degree. Now coming to our next topic, total internal reflection. Light always bends normally as it travels from an optically denser medium to an optically rarer medium. Due to this, light is partly reflected back into the same medium and partly refracted into the second medium at the interface of the two mediums. This phenomenon of reflection of light is called total internal reflection. Here are some examples of total internal reflection. Formation of a mirage. During hot summers, the air present near the ground becomes much hotter than the surrounding air. There is an increase in the refractive index value of air with an increase in its density. Hotter air is less dense and has a smaller refractive index compared to cooler air. Therefore, when the light rays travel straight through the atmosphere and move through the cold air into the hot air layer, it gets bent at the surface. A ray of light gets refracted from the normal and undergoes total internal reflection if the angle of incidence for the air near the ground is more than the critical angle. The observer feels that light is being reflected from the ground. This optical phenomenon is called a mirage. And another example of total internal reflection is sparkling of a diamond. The sparkling of diamonds is caused due to total internal reflection. It is known that the refractive index of a diamond with respect to air is 2.42 and its critical angle is 24.41 degree. Total internal reflection takes place when light from any source makes an incidence with an angle more than its critical angle. This causes multiple internal reflections to occur, as a result of which the diamond illuminates. With that, we come to the end of today's video, and for more information on this topic, check out our website at www.getmyuni.com.